Let A, B, and C be the lengths of a triangle whose area is delta. Prove that A square plus B square plus C square is greater than or equals to 4 delta root 3. And in what case does equality hold? In this problem, we are basically connecting the sides of triangle with the area. Since we know that delta equals to 1 by 2 AB sine C or 1 by 2 BC sine A or 1 by 2 AC sine B. How would we manipulate these inequalities? Uh, we can use rearrangement inequality. So we have A square plus B square plus C square. We use rearrangement inequality first. So that A square plus B square plus C square is greater than or equals to AB plus BC plus CA. Yeah. And now since we can connect and the equality holds if A equals to B equals to C. Okay. And now since we have got AB plus BC plus CA, we can connect these with the area. This is 2 delta by sine C. This is 2 delta by sine A. And this is 2 delta by sine B. Now we can take 2 delta common, and this is 1 by sine A plus 1 by sine B plus 1 by sine C. And this is 2 delta cosec A plus cosec B plus cosec C. And we also know it as a fact that cosec A plus cosec B plus cosec C is greater than or equals to 2 root 3. And if we directly apply that, we will get the required inequality, 2 root 3. This is 4 delta root 3. So we have proved the inequality, and the equality holds. Yeah. And the equality holds only if A equals to B equals to C. But we need to prove this as well. Uh, we can't simply write by knowing the standard formula. Okay. And to prove this, we can use Jensen inequality. Okay. So we need to prove that cosec A plus cosec B plus cosec C is greater than or equals to 2 root 3. Yeah. We use Jensen inequality. For that, let us first check the second derivative of cosec x. Okay. First derivative is minus cosec x cot x, and second derivative is um, cosec x cot square x, and then plus cosec cube x. Yeah, and since we know that cosec x is positive in 0 to pi, and also the cot square x, since it is a square, so this whole expression is also positive. uh, let's say is positive in 0 comma pi. So our second derivative is positive in 0 comma pi. From which you can say from Jensen inequality that f of a plus f of b plus f of c by 3 is greater than equals to f of a plus b plus c by 3. If the second derivative was negative for the entire interval 0 comma pi, then the inequality sign would reverse. Okay, now let us begin proving the inequality. Okay, so we had to prove cosec A plus cosec B plus cosec C is greater than equals to 2 root 3. From Jensen, we can say that cosec A plus cosec B plus cosec c by 3 is greater than equals to cosec of a plus b plus c by 3. So from this, cosec a plus cosec b plus cosec c is greater than equals to 3 times cosec of 16. Yeah, since a plus b plus c is pi in this case, and so it's equals to 3 times root, sorry, 2 by root 3, so it's 2 root 3. And well, yeah, so we have proved this. And one other thing that I would like to remind you is, so here we just checked if the second derivative is positive in the interval 0 comma pi. So why we did that is since our angles a plus b plus c equals to pi, yeah, and this ABC values can only range between 0 to pi. So the values of ABC can only range in between 0 to pi. So we need to check the second derivative in the range 0 to pi only. That is why we did this. And since it is positive in the interval 0 comma pi, so we could use Jensen. And then we proved that cosec A plus cosec B plus cosec C is greater than equals to 2 root 3. Here, and our entire inequality is proved. And our last question is that, and one of the last question is, in what case does the equality hold? The equality holds if A equals to B equals to C, or angle A equals to angle B equals to angle C. That is, if the triangle is equilateral. I hope you got the proof.